Hello everyone. In this case study, you will perform the linear static analysis of a head with shell elements in Solidworks simulation module. By doing this, you will learn how to define a uniform thickness to a shell model, how to define shell elements for a Solidworks for a solid geometry. By doing this, that reduces the computational time without compromising on quality of results, and how to generate high quality curvature based mesh with defining maximum and minimum element size. You will also determine stresses, deformation and factor of safety also. So let's start our study now. First of all, load Solidworks simulation module, then go to simulation tab and click on new study. Give it a specific name, that is shell analysis. Ensure that static type of study is selected. Okay. Our first step is to define shell elements. For doing this, right click on this part and define shell by selected faces. From type, ensure that thin is selected. Select this face, inner faces of, and define its thickness, that is 18 millimeter. And from offset option, select bottom surface option. You can see we have defined a shell element of this 3D solid model. Now apply fixtures, external loads and material to this shell element. So go to fixtures, select fixed geometry options and select this inner edge, this one, and OK. From loads, select pressure, select this inner face, change units to PSI, put value of 500 PSI. Right click on and apply edit material. Select alloy steel. Now go to mesh, create a new mesh, select curvature based mesh from mesh parameters, and maximum element size is 20 millimeter and minimum element size is 5 millimeter. Our mesh has been generated now. Run simulation study now. Wait until solution completes. Evaluate stresses now. From stress tab, go to edit definitions and select units to megapascal. And from chart option, select floating option. So maximum stress in this shell type model is 315 megapascal. That is within material yield strength, whose value is 620 megapascal. Coming to deformations, double click on displacement and you can see that the maximum deformation occurs at its bottom, that is 2.689 millimeter. You can animate this deformation behavior. And our next and last step is to calculate factor of safety. Right click on results, define factor of safety, select first option. So minimum factor of safety is 1.3. That ensures that our design of this head with shell elements is safe because factor of safety is more than 1. So if you have any query, you can ask us in comments of this SolidWorks tutorials. Thank you for watching. Goodbye.